All right, solving exponential equations with a common base. Oh, fun fact. Did you know that the ancient Maya people wrote thousands of books? Only 4 of them survived. The Maya had an advanced writing system that recorded back to the 800 years ago. But they were all burned by the Spanish conquistadors because they were thought to be lies of the devil. Look into the Maya people. It's really cool. It's really cool to look into all these ancient civilizations because there's a lot of things that they share, even though they were all the way across the globe. I don't know, you could go down this crazy spiral of what was happening back then. But anyways, this is not history, this is math. So solving exponential equations. So if they have the same base, it's pretty easy to solve these. So this one, we have 6 to the 3b minus 3 equals 6 to the 2 minus b. Well, a lot like logarithms that have the same base, if they have the same base, we can just cancel the bases. Woohoo. And then you just set exponents equal. So then you get 3b minus 3 equals 2 minus b. And then that's a pretty easy equation to solve. I'm going to just rewrite it so I can solve it using this because I think sometimes it helps. So if I'm going to add the b to this side, you get 4b minus 3 equals 2. Add the 3. Oh, whoops. So then we get 4b equals 5. Divide by 4. So b equals 5/4. Cool. So that's what this equals. b equals 5/4. And then I clicked through all that. See, I skip steps when I'm writing these, so I think I'm just gonna solve them out with my pen. But so this one, so we have 5 to the 2x minus 3 equals 5 to the 4th. Same thing, they already have a common base, so we can just cancel the bases. And we have 2b minus 3 equals 4. So then I can add the 3 over, and we get 2b equals 7, or 2x, I don't know why I'm saying b, and then we can divide by 2. So x equals 7/2. Cool. I click through that. That's what we get there too. Okay. Now what if they don't have a common base? So we have 4 to the 2 minus 3n equals 64. If they don't have a common base, but it is possible to get a common base, let's do that. So let's get a common base here. Now, 4 to the 3rd power is 64, and I just checked it. So I said okay, well, 4 squared equals 16, and you could just use your calculator, and then 4 cubed equals 64. Bingo, that's what we wanted, and I was using 4 since that had a base of 4. Okay, so then I'm just going to replace that 64 with 4 cubed. And then again, I can just cancel those bases, and I have 2 minus 3n equals 3. So I'm going to subtract the 2. I get negative 3n equals 1. Divide by negative 3. So n equals negative 1/3. Cool? Click through that. That's exactly what we get. Let's look at this one. So 3 to the negative 2m power equals 1. Well, exponents are number 3924 to the 0 power. What this is getting at here, if you're I don't even get it, this really equals 1. Okay, anything to the 0 power is 1. I know I've talked about that before, but I just want to get it ingrained in your head. Anything to the 0 power is 1. Okay, so that means that 3 to the 0 equals 1. So I can just replace that 1 with 3 to the 0 power. Then those cancel, and I'm left with negative 2m equals 0. We can just divide by that negative 2 here, which means m equals 0 divided by negative 2 is 0. Cool? Okay, this one. So we have 343 to the 2p minus 3 equals 7 squared. Now here, I want to get a common base again. I know that 7 cubed is 343. And again, I just checked it. So like I did 7 squared is 49. And just use a calculator. 7 cubed is 343. Perfect. That's what I wanted to get this to have a base of 7. So then if we replace that 343 with 7 cubed, so that's going to be 7 cubed. And then that's going to be 2p minus 3 is still the exponent. And that equals 7 squared. But then this is going to be 7 to the 3 times 2p minus 3 equals 7 squared. Which if you wanted, you could multiply this out right now. So that's 7 to the 6p minus 9 equals 7 squared. You can cancel those bases. So we have 6p minus 9 equals 2. Add that 9 over. You get 6p equals 11. Divide by 6. So p equals 11 over 6. Okay, let's see. Click through that, and we still get the same thing. There's more. Okay, this one. So we have 36 to the 2r minus 3 and 216. Now, if you check this, so if we go through 36, well, 36 squared is 1,296, so that's already too big. So then we need to go back and think, okay, well, could I just change both bases? And I figured out that 6 squared is 36. And then 6 cubed is 216. So we're going to use a base of 6 here. Okay. So I'm going to replace that first one with 6 squared. And I'm going to replace 216 with 6 cubed. Now we have the same base, so those can cancel. And I just have 2 times 2r minus 3 equals 3. So then this is going to be 4r minus 6 equals 9. I mean 3. Where did I get 9 from? Add the 6 over. So we have 9 equals 4r. Divide by 4. So r equals 9/4. Cool? Let's do another one. So this one, if we have 125 to the 2x plus 2 and 625 to the negative 3x, well, 125 squared is definitely bigger than 625. It's 15,625. So that's not going to work. But then I went back and I already know that 5 cubed is 125 and 5 to the 4th power is 625. So just start checking numbers. Typically, I'll use probably about the same ones. So then that's going to be 5 cubed times 2x plus 2, and then 5 to the 4th power times negative 3x. Those cancel, and we have 3x plus 2 equals 4 times negative 3x. Those canceling things moved over. This is canceled. This is canceled. So then we can distribute this in. We get 6x plus 6 equals negative 12x. I'm going to subtract the 6x over here. So I get negative 18x equals 6. Divide by negative 18. So we get x equals negative 6 over 18. Which that can reduce to be negative 1/3. Cool? Perfect. And that is it for today. Bye.